At Rescue Education, we have the best explanation every time. I'm Dr. B, and I'm going to help you easily and rapidly learn organic chemistry. If you like this video, you'll love my self-help books. Learn more about them at rescueedu.com. Let's look at a table of all isomer types in organic chemistry, including all the types of stereoisomers. This table shows the relationship of all the types of isomers with examples for each. Let's start from the top. All isomers have the same molecular formula but differ in some way. There are two broad families of isomers. The non-interconvertible family of isomers is called this because we would actually need to break bonds to switch one isomer into another. This is very difficult. The interconvertible isomers, on the other hand, are switched by simple rotation around carbon-carbon bonds, which is usually very easy to do. Let's study the interconvertible isomers first. Interconvertible isomers are called conformational isomers. Usually, conformational isomers are readily interconvertible at room temperature. We cover conformations in Unit 4. We talk about butane conformations in which we rotate around the central carbon-carbon bond and look at the relationships of the methyl groups. We learn the concept of anti- and gauche conformations. We also talk about cyclohexane conformations, and we focus particularly on the most stable chair conformation. We see how chair conformations interconvert by a flip. If there is a methyl group on the cyclohexane, it continually switches between the less stable axial position and the more stable equatorial position. Most isomers we talk about are non-interconvertible. That means we need to break bonds to change one isomer into another, which is extremely difficult to do. So in practice, they are non-interconvertible. Let's expand this region to see the different types. Constitutional isomers are one major type of non-interconvertible isomer. We look at them in Unit 1.5. Like all isomers, they have the same molecular formula, but they have a different order of connectivity of their atoms. This is the type of isomer you probably already know from general chemistry. These types of isomers can have different functional groups, and they can be very different in physical and chemical properties. Stereoisomers, which we study in this unit, have the same molecular formula, and they also have the same order of connectivity of atoms. Stereoisomers differ from each other only in their three-dimensional arrangement of atoms. One branch of stereoisomers are the enantiomers. Enantiomers are isomers which are non-superimposable mirror images. They are chiral molecules and have handedness. We study this in topic 5.1. Enantiomers can have one chirality center, or they can have multiple chirality centers. Enantiomers are extremely similar and are identical in almost all their properties, except they rotate plane polarized light in equal but opposite directions. Diastereomers are the rest of the stereoisomers that are not enantiomers. In other words, stereoisomers which are not enantiomers are by default diastereomers. One category of diastereomers are cis-trans isomers. The cis-trans isomers can occur in molecules with double bonds. We cover this in topics 1.4 and 5.7. We can also have cis-trans isomers in compounds with rings, which we cover in topic 4.4b. Compounds with multiple chirality centers can also be diastereomers, We study this in topic 5.4. These two molecules are not identical and are not enantiomers, so they are, by default, diastereomers. Diastereomers tend to be somewhat different from each other in their physical and chemical properties. If you're using my book, I encourage you to do the extra test your knowledge problems for this topic, so you can be sure you really understand it. All the answers are at the back. This video is closely based on my first semester organic chemistry self-help book. My self-help books are particularly valuable in difficult learning situations, but you can also use them to get an edge or to get a head start. If you want to learn more about my books and videos, how to get the books, or my future projects, go to rescueedu.com.